Hey guys, we are in our free online coaching classes for the JAM examination, and this video will be the lecture 8 on this series. And the topic which I will try to cover is the joints, and the book which I referred is the Structural Geology by Buildings. Welcome to my channel Success Guru and myself Panchanatham, and the topic is joints. So what is a joint? When a rock masses are subjected to external forces, regular or irregular fracture develop in them, and such a fracture along which there has been no any relative displacement takes place are called the joints. So there will be a question in your mind that what if displacement takes place, right? So if the rock displaces along the fracture plane, then it will become fault. And if there is no any displacement along the fracture plane, then it will be the joints. So this is a joint where there is no any displacement, and this is a fault where there is a displacement along the fracture plane. Is that clear? Okay. So the commonly rocks containing a large number of joints which lies parallel to one another, and these parallel joints together form the joint set. And most often two or more set of joints occur in a rock which break them into a rectangular block, and such a two or more joint set together constitute the joint system. And this is the image, that is parallel joints together form the joint set, and two or more joint set together form the joint system. And these are the symbols that are used in the map to denote the joints. The first one is the inclined joint, where this line indicates the strike direction of the joint, and this indicates the dip direction of this joint. And the second one shows a vertical joint, where this line indicates the strike direction, and the third one is a horizontal joint by this symbol. So these are the symbols that are used in a geological map to denote a joint. The next one is the classification of joints. Actually, the joints are classified broadly into two. The first one is the genetic classification, and the second one is the geometric classification. And according to the origin, it has been classified into two, that is the shear joints and the tensional joints. And these joints may be formed due to the four reasons. The first one is the tectonic stresses, that is contemporaneous with the tectonic activity. The second one is the residual stress, that event that happens long before. And the third one is the contraction, that is due to cooling. And the fourth one is the surfacial movement downhill, maybe a rock or a glacier. So these are the four reasons, possible reasons for the formation of shear joints and the tensional joints. And the second one is the geometric classification, and this classification is based on the relation between the strike of the joint and the attitude of the strata. And this can be classified into four. The first one is the strike joint, then the dip joint, then the bedding joint, and the oblique joint. So these are the four categories in the geometric classification. So let us see one after other detailedly. The first one is the genetic classification, that is the tectonic stress. Joints perpendicular to the axis of fold are common in orogenic builds, and such joints may such joints may be called as extensional joint. Here is the image which shows that ABCD is the extension joint, that is resultant from slight elongation that is parallel to the axis of compression. So if the joints that takes place that is parallel to the axis of compression in the folded region is called as the extension joint. The joints parallel to the axial plane of the fold may be a release joint, right? That is, say EFGH. So this one is the EFGH, there is a release joint that is similar to those that forms at right angle to the axis of compression when the load is released. So this is a release joint. And the two set of joints that can intersect at high angle to form a conjugate system are often considered as shear joints, and especially if they are symmetrically disposed about the strain axis. So these are the shear joints which is at a higher angle, right? So the next one is the residual stress, that is the residual stress may cause joints. The first type is the tectonic stress that may not be fully relieved, and the second one is the rock that consolidated at a deeper depths at high time lithostatic pressure when reaches near the surface due to erosion will tend to expand. Such an expansion leads to the formation of joints parallel to the surface. And a very good example is that the exfoliation dope that are formed in some of the granitic rock. So you can see here this granitic rock, take an example, might have formed at a greater depth where the lithostatic pressure is high, and due to erosion what happened, the top portion is removed, and as the stress is removed, this granitic rock tend to expand, and that results in exfoliation dome. The second one is the contraction, that is joints resulted from shrinking of rocks, and the shrinking may be due to the cooling or desiccation. The igneous rock contracts at cooling, and the columnar joints is the best example of this type, and the mud and silt contracts due to desiccation. So this is a good example of the joints which has been formed due to the contraction as well as cooling. The third one is the surfacial movement. You can see crevasses on the glacier which are formed due to the movement of glacier downhill, right? And such a crevasses will come under this category, that is the surfacial movement that creates the joints. Is that clear? The genetic classification. The second one is the geometric classification, which is quite easy for you to remember. So let us consider this dark black color band as a bedding, right? Bed. So the first type is a strike joint, the joints that tend to be parallel to the strike of the country rock. So you can see here there are two joints. So according, if this is a bedding, that is a rock, so this will be the strike direction, right? So parallel to this there are two joints, that is MNO and BDEF. So these two can be a strike joint. The second one is the dip joint, that are parallel to the dip of the rock. So as this is a rock formation and this direction is the dip direction, so you can say this ABCD will be parallel to the dip direction. So this can be a dip joint, and this GH and I, this also parallel to the dip direction. So these two are the dip joints, right? So which is parallel to the dip direction of the rock formation. And the third one is the bedding joint, where the joints are oriented parallel to the bedding plane of the strata. So you can see here that J, K and L, which is parallel to the bedding plane. You can see the strike is matching with the strike, and dip of the formation is matching with the dip of the joint. So such a type of joint is called as the bedding joint. And the fourth one is the oblique or diagonal joint, which runs in direction that lies between the strike and dip. So this will not match with the strike direction or dip direction, and this kind of joints are called as the oblique or diagonal joints, that you can see here, this TQRS and STU. These two are the diagonal joints which will not be parallel to strike or dip or anything, right? So these are the two classifications. There is genetic classification as well as geometric classification. So the next question in your mind will be the what is the reason for the studying of joints, right? The following are some of the applications of the joints. The first one is that joints are mainly used in quarry operation, because joints are the weaker planes along which you can break the rock without any more fracturing, without applying more pressure, right? So joints are very useful for the quarrying operation. And the second one is that in engineering project, what happens when you are, say for example, take a tunnel as an example. If you are working in a tunnel, if you are preparing a tunnel, what happens if the rock is so much fractured, then you have to give a strong lining as a support. If the rock is unfractured and unjointed, there is no any need of such a safety measure, right? So in an engineering project, joints should be studied in a detailed way for the safety purpose. And the third one is the landslides. You can see the landslides, which is due to the joining, that is joints, results in landslides. According to the orientation of the joints, there will be a landslide or there may not be a landslide. So during landslide analysis, the joints were studied in detail. And the next one is the main source of groundwater in crystalline terrain. As you know that the sedimentary rock consists of pores, and which can be porous and permeable, and that yield you water. But if you are in a metamorphic rock terrain or igneous rock terrain, there will be no much pores, right? So these joints act as a porous medium that can transport water and also store water. So the main source of groundwater in a crystalline terrain is a joint. And the next one is that deduce the orientation of the regional stress direction. So to understand the overall stress direction of the whole area, you can study the joints, which will help you to find out the regional stress directions, right? So I hope I have explained the what is a joint, the classification of joint and the importance of joint. As mentioned earlier, I have created the WhatsApp group, and if you want to join this WhatsApp group, you can mail me your details. I can join you in that. And I group my videos according to the category that you can check in my playlist. You can connect with us by mail, Facebook, and Instagram, and these are the links. You can also support us by like, share, and subscribe. Thanks for watching. Have a great day.